Hey guys, Mr. Riz here. So I'm going to help you guys out on the second day of the 323 assignment here, parts 3 and 4. So we're going to look at combining the for loop with the range function, and then we're also going to look at the while loops and also the modulo operator. So we got two quizzes here to get you guys started, or two assignments maybe, and let's go ahead and let's preview those. All right, so combining the for loop and the range function, and this is used a lot of times in Python. So you have used the loop to iterate a list, as in like for every post in the list or for every answer and answer key. The for loops can also be used to iterate a specific number of times. In fact, for loops and the range function are also used together in Python. So here's an example of a for loop that iterates 10 times. So for every number in range 1 through 11, so we're going to start with 1, go to 11, we could print that number. And you can see here, we start with 1, we print that, then 2, 3, 4, 5, 6, 7, 8, 9, 10. We stop there because we went. So that made the list or the loop iterate 10 complete times. So given the example above, what we're trying to do here, and you can see here, we're going to make a list that prints off the numbers 1 through 11 exclusively. So we would start out our program for every number in range. All right, so 1 through 19, we'd have to do 1, comma, we don't want to do 19, go to 20. And do print number. So just to see this, we'd get 1, 2, 3, 4, 5, 6, 7, 8, 19. Okay, we stop. All right, then next, what we want to do is print off for every numbers 20 to 1 inclusively. So for every number in range, same thing, we got to think about what would go in here. 20 to 1, so we'd have to go 20 down to 0, down by 1. And then, I forgot the colon, that's why I didn't look right. Print number. So let's see, we're going to make sure we have all of these on here. So here we go. We got 1, 2, 3. You know what I'm going to do here, just to save some space here, or print. I'm going to put a print in between that so I can see where it splits off. So if I scroll up here, okay, there's the 1 through 19, and then 20, 19 going down, and we stop when we get to 1. All right, now what we're going to do next is even numbers 2 through 10 inclusively. So I'm going to put another print here, blank, just to give me some spacing. For every number in range, okay, how do we go 2 through 10? I'm going to start with 2. I want to go past 10, so maybe I can put 11 or 12 here. And if I want to go even numbers, I'm going to go by 2. So 2, 4, 6, 8, those are all the even numbers. So for every number in range 2 to 11 by 2, we print the number. See if that works. All right, 2, 4, 6, 8, 10, that's the end. Okay, good. I'll do another print blank, and we have one last one. Print the odd numbers 9 to 1 inclusively. So for every number in range, all right, we're going to start with 9. We're going to go down to 0, and we're going to go down by 2 each time. So 9 going down by 2, go to 7, then go down by 2, go down to 5. So those are all our odd numbers. All right, we could print number. Let's see, 9, 7, 5, 3, 1. All right, when you guys are done here, you can either upload this file or just click submit on Ripple, and I will grade that when you guys turn that in. All right, now when you guys submit, it'll probably say you have one unanswered. Just press OK, because you probably just submitted it on Ripple. That's the loophole we have to go through. All right, let's do the next quiz and kind of work with the same thing as well. So here we go. Let's preview this one, or you guys will actually start it. All right, so the while loops. So another type of loop is a while loop. While loops check for a condition and continue to loop until that condition is true. So while loops are used in block programming as an example. So like while the test, all right, so while we get the user input does not equal quit. So as long as the user input does not equal quit, we're going to make this visible true. You know, you can think about this like when we make our hangman game, we're going to do like while the word isn't the guessed, or we could do just a loop like until we get to this number, keep going. So the while loop would just keep going until we get a certain condition met. All right. So the while loop has a header where we have a header is the keyword followed by an expression or evaluation. And then we have our indented block of code to execute. So So just like a for loop, we have our for statement and we have here. So while loop has like while the user input does not equal quit, we do the part of the loop that goes through. And we probably would want to have somewhere in our loop where the user could change it to quit to end the loop, but sometimes we'll make while loops that go on forever. So here we go. Like here's an example of a while loop that works out. All right, so if I have x equals 0, while x is less than 11, print x, and then we're going to make x go up by 1. So we would have this start out with e 0, we print off, or we print 0, and then we make 0 go up to 0 plus 1, so then it goes up to 1. So that goes through the loop again. Now it's 1, we print it off, we make it go up to 2. We print that off, we print 2 off, we make it go up to 3. We print 3 off, we make it go up to 4. We print 4 off, we make it go up to 5. We print 5 off, we make it go up to 6. We print 6 off, we make it go up to 7. We print 7 off, we make it go up to 8. We print 8 off, we make it go up to 9. We print 9 off, we make it go up to 10. We print 10 off, we make it go up to 11. And then when we loop back around, 11 is not less than 11, so we don't do anything else. So let's write a while loop that prints the even numbers from 30 to 50. So we can make like x equal 30. We'll say, well, like while x is less than, do like 52, because we want to include 50 here. We'll tab this. Oops. We can't tab because it'll go in, but we'll space it in here. We'll say like print x, and then make x equal x plus 2. So we could test this out, but I'm just putting this here so you guys can kind of work with a coding, typing out coding that's not in your coding format. So, all right, so that should work out. So we'd start off with 30, make it go up, we print that off, make it go up by 2, so it's 32, and then that would go up next and keep going and going, and it'd stop. You know, we'd print off 50, make it go up to 52, but we would stop. It's not less than. Another thing we could have done too is we could have made it 50, but made it less than or equal to. That would work as well. All right, so the modulo operator, this one is kind of weird. This modulo operator gives us the remainder of the value. So a couple examples here that we are going to do. Oh, you know what? I did not finish this quiz. I need to put the Ripple here, but I'll open up a Ripple page and have you guys submit it that way. Actually, I'll probably make 2 ripples here. Okay, so what we're going to do here, modulo gives us the remainder of the value. So if I have like 4 modulo 2 would be 0 because 4 divided by 2 has 0 remainder. If I did 4 modulo 3, that would be 1 because 4 divided by 3 has a remainder of 1. If I have 7 modulo 2, that would be 1 because 7 divided by 2 has a remainder of 1. I could do like 7 modulo 5, that would be 2 because 7 divided by 5 has 2 as a remainder. So modulos are nice because they repeat over and over again. So what we're going to do here next is to make these for loops, or we're going to make loops. I guess we can use for loops, or no, we want to use while loops here that show these numbers. So let me open up Ripple here. I should have had a Ripple assignment open up already, but I'm going to split screen this here since I don't have it. I'm just going to do my ripples here. And we will go through, here we go. So we're going to make a couple while loops here. And I'll do the same. Okay, so let's do x equals, okay, we'll start off with 1. That's the first one. So while x is, you know what, probably be easier, less than or equal to 5. Let's do that kind of technique here, less than or equal to. We can say print x, and then we can make x go up by x equal x plus 1. Let's see what that looks like. 1, 2, 3, 4, 5. So that's perfect. Okay, so I'm going to do print space, and then we're going to have to make another one. Now we can reset x here and make x equal to, so after that loop gets somewhere, start with the next one, 10. So while x is, now if we're going down, we're going to think we want to be greater than or equal to 1. We're going to print off x, and then we make x equal x minus 1. So let's see, we got 1, 2, 3, 4, 5. Then we got 10, 9, 6, 7, 8, 4, 3, 2, 1. Okay, that's good. All right, next we want to do even numbers 2 through 10. So, okay, x is equal to 2. We're going to start there. While x is, let's see, less than or equal to 10, we can print off x and then make x equal to x plus 2. So we're going to go up by 2 to get the even numbers. Oh, I forgot a print statement, so there's no spacing there. I can't really tell where my one begins and the other one doesn't. All right, there are 2, 4, 6, 8, 10. Okay. Next, what we're going to do here is to count all the odd numbers, use modulo operator and a conditional. Okay, so this would be the tricky part. So x equals, we're going to start with 9. And so we'll say while x is less than or equal to 1. All right, let's do this. If x modulo 2, we want the odd numbers, is equal to 1. So if we divide it by 2 and then we get a remainder of 1, we'll print off x. Now we could put an else statement here, but let's see what that looks like. Oh, and of course I forgot the print statement, like I forgot the other one, print x. Oh, you know what? And I realized that this isn't going to work out because x did not, x got changed to 9. That's weird. I got a 12 there at the end there. Oh, no, I just want a blank print statement. Oh, and this one didn't work because I have a less than symbol. It should be greater than. If I'm making it go down, we want it to be greater than. All right, so, okay, I get 999 and it doesn't stop ever putting 9s. And it's because after the if statement, I don't change 9. I'll make x equal to x minus 1. There we go, 9, 7, 6, 5, 4. So what happens here in this one? We start out with 9, and 9 is greater than or equal to 1. Does 9 divided by 2 have a remainder of 1? It sure does. We print off 9, and we make it go down to 8. 8 is greater than 1. 8 divided by 2 has a remainder of 0, so we don't print off that. We just move on to the next number, 7, which works out. 6 does not. 5 does. 4 does not. 3 does. 2 does not. 1 does. We make it go to 0, and it stops when it gets to 0. All right, so this should be your answer here. I forgot I need to put that ripple page there, and I will do that next so you guys won't see the mistake. All right, guys, we are finished with this part. We literally have one more assignment due before we start our games. So I'll see you guys next time. Have a great one.